Welcome, Algebra 1 students, to Unit 2.4, Solving Absolute Value Equations. You're hearing the voice of Mr. May, and this will be part 1 of a two-part lesson covering absolute value equations. So you will see a second Unit 2.4 instructional video that will be part 2. This is a relatively lengthy lesson, so I'm going to divide it into two parts to make sure that we fully understand the basics of absolute values before proceeding to the more complex occurrences. As always, please make sure you have your guided notes available. We will be completing those as we proceed through the lesson. And with that, let's begin. Our learning target is I can solve absolute value equations. And so the focus again is on solving, and we know that we will be working with equations because if you recall from previous units, we solve equations and simplify expressions. So in the case of these absolute values, we have equations, therefore our goal is to find a solution. Absolute value. The definition being the distance of a number from 0 on the number line. The important and operative word being distance. Distance is a concept that can never equal a negative number. We never travel negative distances. So for example, if I travel from Danville to Lexington, I travel approximately 42 miles. When I return home from Lexington to Danville, I do not travel a negative 42 miles. I still travel 42 miles. It's just in a different direction. And so we could apply that concept when thinking about absolute values. If I consider 0 being in the center of this number line, I can then move two directions from 0. I can move to the right or the positive direction. But I also have the option of moving to the left or in the negative direction. Now, this is not to be confused with distance. Direction is not to be confused with distance. So as an example, if I were to move in the positive direction 5 units, okay, the distance that I have traveled or moved from 0, the distance is a positive 5. However, I also have the option of traveling in the negative direction. And if I travel in the negative direction, the same number of units, my location at the end will be negative 5. So my location is negative 5, but when I look at the distance that I traveled from 0, I still traveled a distance, so the distance is still a positive 5. I have still moved a total of 5 units from 0. And so the direction may be positive or negative, but in either case, the distance that I have traveled from 0 will always be positive. And so when we consider the notation of absolute values, the first thing we notice is that we now have a second grouping symbol, and this being brackets. As you may recall, we have altered PEMDAS, which is parentheses, exponents, multiplication, division, addition, subtraction. We had altered that to, or modified it to GEMDAS, or grouping exponents, multiplication, division, addition, subtraction. That is because we are now increasing the number of grouping symbols that we use. And in this case, we are now introducing absolute value brackets. Now, with an absolute value bracket, yes, the terminology that we use when actually reading an expression or equation that include them is the absolute value of. We need to think in our minds, as we're saying that, we need to be thinking the distance from 0 is, and then whatever the value is contained inside those absolute value brackets. And so, for example, let's look at this first case. When I read this just as an expression, I would say the absolute value of 5. However, what I need to be thinking of is the concept of the distance from 0 is 5 units. That always reminds me that I am converting any negative into a positive because I'm referring to the distance from 0. And so in the second case, I now have a negative 5, but when we consider it in the context of our number line, and again moving in the negative direction toward negative 5, I would still read this particular instance as the distance from 0 is 5. So the absolute value of negative 5 is equal to 5. In both cases, we have the absolute value of 5 is equal to a positive 5. And we also have the absolute value of negative 5 is equal to a positive 5. But the way that I am thinking of this conceptually is the distance from 0 is 5. Now, I'm not including a unit necessarily, but were this an instance where we gave meaning to these numbers, you could include any applicable unit depending on the circumstance or situation. And so, looking at example number 1 with that highlights learning target number 2.4a, we use the concept of absolute value equations or absolute values in general being distances from 0. And when we think of that conceptually, we realize we must look for solutions that account for all possible distances from 0. And when we consider all the possible distances from 0, we realize that there are 2 possible distances. There is a distance in the positive direction, and there is also the instance of the negative direction. And so these are all the possible instances of the value being a distance from 0. And when we look at the example number 1 specifically, we are told that an expression, x plus 1, or the absolute value of x plus 1, and again, if I think of it in terms of the distance from 0 of, in this case, x plus 1 is, we're told, 5 units from 0. And so when I think about what is 5 units from 0 on my number line, I immediately realize that I have 5 units from 0 in the positive direction. But then I need to also realize that I have 5 units from 0 in the negative direction. And so both of these instances are a distance of 5 from 0. Well, what did we say was 5 units from 0? Well, our expression contained in the absolute value brackets. And so what I'm going to do is I'm going to rewrite that expression, the distance from 0 that we are given. So we know that x plus 1 is 5 units from 0 in both the positive and negative direction. In order to solve for x, what I must do is set both instances equal to their respective distances from 0 in the positive and the negative direction. And so I have set the negative distance, or not the negative distance, I'm sorry, the negative direction. And I have also created an equation representing the positive direction. At this point, we use our algebraic properties to solve for x. And so I'm going to use the subtraction property of equality to subtract -1 from both sides. And I have a solution of x equals -6. In the second instance, I'm going to use the same subtraction property of equality to subtract -1 from both sides and receive a value of x equals 4. Now, there's a possibility that each one of these is a solution. So what I must do is substitute back into my original equation each of these values of x to see if I have a valid solution. So in the first case of x equals -6, I'm going to substitute the -6 back in for x. And when I do that, I end up with an absolute value of -5 is equal to 5. And once again, thinking the distance from 0, if the distance from 0 of -5, the distance of -5 from 0 is 5. So that is a valid solution. Let's look at the case of x equals 4. Okay? If I were to rewrite and substitute the 4 in for x, I would have an equation that reads the absolute value of 5 is equal to 5, or the distance of +5 from 0 is 5 units. That is also true, and so 4 is also a valid solution. And so the important concept is to realize we must solve for all possible distances from 0, meaning we must recognize that we can move both in the positive direction and also in the negative direction from 0. Example number 2, highlighting learning target number 2.4a. Once again, we have an equation with an absolute value grouping, and what we must realize is that we consider these absolute value grouping symbols as the distance from 0. And in this specific instance, the distance from 0 is x minus 3. And so if I were on my number line to place 0 in the center, I must solve this equation for all possible distances from 0. And so I have to consider the positive distance from 0, and I must also consider the negative distance from 0. Now, unlike previous instances where the right side of the equation was a constant or a number, we have a variable on the right side. So I do not know exactly where this will fall. This particular expression on the right side of the equation will fall as a distance from 0, either in the positive or the negative direction. So I just want to represent that by placing it somewhere on the number line to the right or in the positive direction from 0. But as we may recall, we have to also account for the negative direction, the other distance from 0. And so I'm also going to place the value to the negative direction. However, we also have to realize that we now have moved in the negative direction. That is why I would encourage you to always put parentheses around the entire expression outside of the absolute value grouping symbol, okay? Because when we set up our equation, we are going to need to distribute the negative into the parentheses. So, secondly, when creating our equation, we have to realize that we have been told that we are an x minus 3 distance from 0. And so our x minus 3 distance from 0, once again, we have to consider both the positive and the negative directions. And so what I have created are two possible scenarios where we have moved a distance of x minus 3 from 0. So in order to solve for x, I need to establish or create an equation. And in this case, I'll create two equations, one representing the negative direction and a second representing the positive direction. And so here's our positive direction. Here is our negative direction. Now, using our algebraic properties, we can begin solving. And as I had mentioned previously, we have to distribute this negative, and since there is not a value explicitly written, we can imply the 1, so we are going to distribute a negative 1. And so the left side of the equation does not change. And when I distribute the negative 1, I end up changing each of the signs inside the parentheses, removing those parentheses, and at this point I can simply finish solving for x. And so as I complete this particular equation using the properties of equality, I eventually arrive at a solution of x equals negative 1. That is my first solution. In the second equation, because there is not a negative in front of the parentheses, that is an implied positive. Well, if I were to distribute the positive, I would be distributing a positive 1 using the multiplication property, the identity property of multiplication, where anything multiplied by 1 is itself. Essentially, nothing's going to change inside the parentheses. So for that reason, I can simply remove the parentheses and begin solving. And so as I work to solve this equation, once again using my properties of algebra or properties of real numbers, And looks like I have written a typo here. So let me fix that real quick. And 2x, this was 2x plus 6, which makes this a 2x plus 6 because I can just remove the parentheses. 6 plus 3 is 9. Okay, that corrects any error that I had written. So now I have negative x equals 9. It is not the best mathematical practice to leave a negative x. So again, we have an implied 1. So in order to remove a negative 1, I need to divide by negative 1 on both sides. And I have a solution of x equals negative 9. So what I need to do now, I'm going to rewrite my answers down here just so we can see them clearly. The first case, or the negative direction, was x equals negative 1. The positive direction was x equals negative 9. What I need to do is I need to check my solutions. Well, when I look at my original equation, I know that it cannot equal a negative number, okay? Because absolute values represent distances. Distances must be positive. For that reason, this side of the equation must be positive because it represents a distance. Must be positive. So if I were to substitute in either of these values and I get a negative number, then I know that that is not a valid solution. So let's begin with x equals negative 1. If I substitute in negative 1 for x, if I were to substitute in negative 1 for x, so I have 2 times a negative 1 plus 6, my answer would be a positive 4. Well, that's a valid solution. And if I look inside the grouping absolute value and negative 1 is substituted for x, negative 1 minus 3 is negative 4. The absolute value of negative 4 is 4, therefore I have a valid solution. In the second example, or second solution option, I have a negative 9. Well, if I substitute negative 9 for x, then I have a value of negative 12 on the right side of the equation. Well, I immediately know that absolute values represent positive distances. So if I have a value of negative 12, it does not mean that I solved for x incorrectly. What it means is that I have an extraneous solution. And essentially what an extraneous solution means is that it is an invalid solution. So almost considered as, in this case, no solution in the positive direction. And so I have one valid solution, x equals negative 1, representing the negative direction and distance from 0. And so with this example number 2, this concludes part 1 of Unit 2.4, Solving Absolute Value Equations. If you have any questions, please go back and review your notes, re-listen to parts of this instructional video, rework the examples, and if you have any additional questions beyond that, please ask a math teacher. We are more than happy to help clarify any questions you may have. And as always, have a great afternoon, and we look forward to seeing you in class. Please look for instructional video part 2. It will conclude the lesson on absolute value equations. And with that, we do look forward to seeing you in class.